Alright guys, welcome. We are now doing section 1.6, which is talking about a little bit more with domains of functions and adding, subtracting, multiplying, and dividing functions. Alrighty? So, we're going to go ahead and jump right into example 1, just like normal. So it's going to say to find the domain of a function, of each function. And I'm going to go ahead and apologize in advance. I am recording during my planning period, so you are going to hear a series of bells since my planning is launched. So I apologize for that. Hopefully I'll be getting that software soon and this won't be an issue. So let's say we have function f of x defined as x squared plus 3x minus 17. Now, what you're doing when you're finding a domain is you want to give me all the places that the function exists. So if you were to graph this in your calculator, would be one method. The other thing is to ask yourself, what causes functions to not exist? Some problems is if you have a denominator of 0, right? That's going to cause major issues. If you have a negative under a square root, okay, those are going to be cause problems. So in this case, there's nowhere where you have issues with the function. So it's negative infinity to infinity. Okay? And what we'll do after we do a couple of these problems is I can show you them on the graphing calculator so you can see how it's going to work as well. Alrighty? Let's say I have function g of x, which is defined as 5x over x squared minus 49. So the first thing we're going to need to do is to go ahead and try to factor this denominator. So if you notice, this is the perfect difference of two squares. So I'm going to rewrite it as 5x, x plus 7, x minus 7. Right? Because if we FOIL it, we get back to x squared minus 49. So we have a denominator in this one, which means that any time this denominator becomes 0, we've got problems, that our function's going to do something crazy at that point. It's going to become what's called an asymptote. So you cannot let either one of these equal 0. So we end up that x could not be negative 7, and that x cannot be 7. Okay, so the way you're going to write this is you're going to do in interval notation is what I like to do. So at negative infinity, the function exists. It is happy, it gets to negative, and then it stops. So at negative, there is that moment of time. Now the problem is when you graph this, sometimes you'll see it, and sometimes it's so faint you won't. Okay? Then again, at negative 7, it picks up and everything's hunky-dory until positive 7. And then we have another glitch because this denominator has become 0. Then it picks up again at 7 and goes to infinity. Okay? So think for a minute why I'm using the parentheses as opposed to the square brace. And that's because at negative 7, the function cannot exist because the denominator becomes 0. Alright? Alright, let's try one more, and then we'll see if the graphing calculator can help us see any of these at all. Alright, so let's go back. We have h of x is equal to the square root of 9x minus 27. Okay, so now we have a square root. And we know that underneath a square root sign, if there's a negative number, we're going to get something called an imaginary number, which means the domain doesn't work there. So what I need to know is where is this value greater than or equal to, right? Because it can be equal to. So 9x minus 27, I need it to be greater than or equal to 0. Alright, and I'm just going to go ahead and graph and solve that. Alright, so I get 9x is greater than or equal to 27, so x is greater than or equal to 3. Now this time, the function at 3, if I plug 3 in, it's still valid because I can take the square root of 0. Right? If I plug in 9 times 3 minus 27 is the square root of 27 minus 27, square root of 0, which is 0. So 3 is part of my domain, and then it goes on to infinity. So this time I'd have my square brace and my parentheses. Alright, so I real quick want to go ahead and show you just graphically how you can test these. Alright, so I've gone ahead and I've typed the first one in to my y equals, and when I graph it, there's my parabola. And so I know that its domain is from negative infinity all the way to infinity. Okay? Let's go back and type in the second one. Now, for those of you who are typing it in, make sure you put parentheses in the denominator. So I need x squared minus 49. Graph. So do you see right here? This is a vertical asymptote, and here as well. And if you look, that happens at negative 7 and 7. Okay, so that's where this function gets close to it, but never touches it. Alrighty, and then if we look at the last one, we want the square root of 9x minus 27. This one's harder to see, but it really does begin at 3. Well, it's especially hard to see when you have a ginormous glare on the screen. There, that's better for you. Alright, so it begins right there and continues. Okay, so I hope that helps you figure out how to do domain of functions. Now let's talk about how to add, subtract, multiply, and divide functions. Alright, so example 2. Find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Then state the domain. Alright, well I saved you from part of that, Belle. I'll try to start recording these after school, but at least while I'm still trying to catch up this first week, it may be that you have to listen to that obnoxious lunch bell. Alright, let's say that you have f of x is equal to x minus 5, and g of x is equal to x squared minus 1. Alright, and the first thing we're going to do is find f plus g of x, which simply means I'm going to add this function and this function together. So I'm going to add them together, I'm going to combine any like terms I have, and then I can give the domain. Okay, so I'm going to go ahead and put them in order. X squared plus x, I have a negative 5 and a negative 1 gives me a negative 6. Now I need to give the domain. So again, this is going to be a parabola, so it's going to be negative infinity to infinity. I don't have a denominator, I don't have a square root. Okay? Alright, let's do subtraction. Subtraction a little bit trickier because you got to make sure that you distribute this little negative sign. Okay, so I'm going to do f of x minus g. Okay, so I'm going to take function x, function f of x, x minus 5, minus, and I like to keep it in parentheses, x squared minus 1. Because now this negative, remember, is going to get distributed. So I really get x minus 5 minus x squared plus 1. Right? Because a negative times x squared is negative x squared. Negative times a negative 1 is positive 1. And now I just go ahead and combine my like terms. So I have x squared, negative x squared, plus x minus 4. Okay? Again, do I have a square root? No. Do I have a denominator? Nope. So my domain is negative infinity to infinity. Alright, let's try the next step, which is going to be to multiply. Alrighty. So, function f is x minus 5, function g is x squared minus 1. And then this is what we were doing on the first day of class, where you're just going to go ahead and FOIL these, or box them. Alright. So I'm going to go ahead, I like FOIL the best. So I have x times x squared is x cubed. X times negative 1 is negative x. Negative 5x squared. Negative 5 times negative 1 is positive 1. So I'm going to go ahead and put them, remember we always want them in descending order, minus 5x squared minus x plus 1. This is a cubic function, so he's also still has no denominator, no radicals, so his domain is negative infinity to infinity. Alrighty. Alright, let's try the last one. We want to divide the functions. So I'm going to put function f in my numerator, function g in my denominator. So now I have a denominator, which means I need to be careful, because there is a chance, well, in fact there is going to be a possibility for this to become 0, which is going to be a big problem. So the first thing I need to do is be able to find out when that happens. So I'm going to do that by factoring my denominator. So I get x minus 5, I get x plus 1, x minus 1. Neither of these can become 0. So if you need to, you can kind of take a sidebar and go off to the side, and you know that x plus 1 cannot equal 0, and x minus 1 cannot equal 0. So x cannot equal negative 1, and x cannot equal positive 1. So those are the points where those vertical asymptotes will arise. So my function begins at negative infinity and travels all the way to negative 1, and it hits its first asymptote. Then it goes from negative 1 to positive 1, and then from positive 1 to infinity. Okay? And let's go back and label this number 1. So I'm going to go ahead and at least try to get the next one in here. Okay? Alright, so number 2. Let's say we have f of x is the square root of x minus 3, and g of x is the square root of x plus 1. Alrighty. Now, adding and subtracting again are very, not the tough ones. It's the multiplication and the division that can get to you. Alright, so I'm going to take the square root of x minus 3 plus the square root of x plus 1. And the question is, can I do anything with them? And actually you can't. This is as far as they can go. It's kind of like if you did the square root of 3 plus the square root of 5. You can't put those together. They would actually have to be the same underneath the square root. Okay, so believe it or not, we're finished. Now all you have to do is say, is there any place where this function ceases to exist? Well, I've got some radicals, which means they cannot become negative. So I need to know x minus 3 has to be greater than or equal to 0, and x plus 1 has to be greater than or equal to 0. So I get x is greater than or equal to 3, and x is greater than or equal to negative 1. So, before you jot down your whole stuff, think about it for a minute. If x is negative 1, will it work in function f? So if I plug in the square root of negative 1 minus 3 is the square root of negative 4, which is 2i. So negative 1 won't work for function f. Would 0 work? 0 minus 3? No. So really, this is going to be my domain of the addition of the functions. So I'm going to start at 3 and go to infinity. So what you need to do is pick your 2 and then just substitute into both of them and make sure they work for you to be able to figure out which one it is. Okay? Alright, let's try a subtraction. F minus g of x. So I'm going to take function f minus function g. Again, I can't put them together because the terms underneath the square roots are not the same. So this is my answer. The only thing I have to do again is figure out the domain. Well, isn't this the same thing as number 1? So its domain is still 3 to infinity. Alright, let's try f times g. So it's going to be function g, f, square root of x minus 3, times square root of x plus 1. Now, could you do square root of 3 times square root of 5? Well, let's see. You can't see a doggone thing that I've just done. There we go. So can you multiply those? You couldn't add them, but you can multiply them and get the square root of 15. So I multiply the terms and they stay underneath the radical. So what I need you to do is multiply x minus 3 times x plus 1. So you're either going to box it, you're either going to FOIL it, whatever you need to do. So I get x squared, let's see, so I'm going to FOIL first outer plus x, inner minus 3x, last minus 3. So I get x squared minus 2x minus 3. Alright, but again, this has a square root, a radical. So this has to be greater than 0, greater than or equal to 0. Again, these have not changed. So they're products, right? If I factor this, wouldn't it take me right back to here? So again, my domain is going to still be 3 to infinity. Alright, let's do the last one, and we're almost done. Let's do f divided by g. So that's the square root of x minus 3 divided by the square root of x plus 1. Now this time you've got several things going on. You can't let the denominator become 0. So again, it's the same factors. We know that x has to be greater than or equal to 3, or x has to be greater than or equal to negative 1. We know that negative 1 doesn't work here. So the only thing that it could be is, does 3 work? So we're going to check that down here. And is 3 plus 1 is the square root of 4. Square root of 4 is 2, so that's okay. So again, our domain is the same, 3 to infinity. Okay? If you ever get stuck, take a minute, plug it in, and see if your calculator can help you. Alrighty? Okay, I only want to do one more thing with you, and then we'll finish up our notes in class tomorrow. I want to go ahead and do example, I think we're up to 3. Express h of x as a composition of two functions. So we're going to say that two things made this function. Okay? So in other words, if we took it apart, the innermost function is g of x. So g of x would be x squared plus 5. And f of x is the outermost function. So ignore this, and it's just the square root. But we just can't take the square root, so it's just the square root of x. So it's just separating them into two terms. Alrighty? Okay, so I will see you guys tomorrow, and we'll do a little bit of composition with functions at that point. Have a great night. Don't forget your practice problems. Bye.